Hi all. Welcome to my talk, Re-exploring Git's branching model for the classroom. My name is Roy Vanegas. I've been teaching for over 15 years now. I teach classes in web design and I teach classes in more advanced engineering spaces. In the web design space, usually those students are less technically capable, and in my engineering classes, they're more advanced. Nonetheless, I use Git or GitHub almost exactly the same way in both of those classes. I've developed a workflow over the years that it makes sense in terms of how it is that I share examples with students. I've been following a convention that I've used inspired by the BEM naming convention for sharing assignments with students, creating a branching model that makes sense for them to submit their work back to me. And it has proved to be successful. There's a learning curve, so there are pros and cons to implementing this Git-based workflow in class, but overall I have found that it's pretty successful. So over the course of 20 or so minutes here, I will discuss how I do this in class and what are both the pros and cons of using Git in this form for teaching engineering and design classes. So let's take a look at, for example, grading. So I'm looking at Linus's branch here. So let's say the document that they being the students, that they were supposed to edit is the document readme.md, just to keep matters very simple. In reality, of course, it might be a JavaScript file, an HTML, CSS file, C file, whatever. In our case here, so I take a look, okay, here's Linus's work, and maybe I'll come back over here to the GitHub desktop UI, and I'll check out Dennis's work, reload the page. So there's Dennis's work. It's all in the same document. Something to keep in mind here is that the instructions all say that the students must work in a handful of files when they submit a project. So if they're going to submit other files, those files should be dependencies over the main file. So for example, if it's a website and the website has to start at index.html, they can have other documents, but I must have a springboard somewhere where I can start to look. And that's the first page I usually load. So if I say the CSS document must be called style.css, it must be in a folder called CSS. The first document should be called index.html, and any JavaScript files should be in a JS folder, and they're linked in the index page and so on. Then I always have a starting point. So of course, in this example here, we don't have any of those files. In this case here, all we're doing is just looking at one file, and in a simple scenario where I'm simply grading a single file, this makes the work much easier, right? So come back over here. Maybe I'll take a look at Junio's work. Come back, reload the page. There's Junio's work. So it's very easy to grade because I'm simply looking at one file or multiple files, but I know where to start, and I don't have to go around digging for files. It's all been submitted into one place, and the work of grading work is made much easier. So now let's talk about how it is that I use assignments in class and how I share those assignments with students. So I have a fake repository here that represents an assignment called assignment 1, JavaScript programming in class CS 666, fall 2021. Okay, so the first thing I do is I rename the master branch. So GitHub is now calling the default branch main and no longer master. Of course, we all know that's just a convention. We can name that default branch whatever we want. I always rename that branch to a branch called don't work here. That's because each student will end up getting a branch in his or her or their name, and that's the only branch they can work in. So in essence, there are different swim lanes, if you will, and they can only swim in their own lane. So I have this default repository here, and I've got no other branch. So I'm going to create a branch. And I'm going to call this branch don't work here. Now, in a previous version of GitHub, you used to be able to see the entire string don't work here. on the GitHub page. That's no longer the case. They've redesigned their user interface, and it's different now. So let's push this. I don't want to type all this out, so let's just copy this, push this up. So if we go to the web page, refresh here, if we check out the don't work here branch, now R and E are cut off, but before you used to be able to see don't work here. So that's an indicator to the students that they should not be working in that branch. Now, the master branch or the main branch is the default branch, so I need to remove that branch. But before I do that, before I can delete the local branch or the remote branch, I need to unprotect it. So I go to settings, go to branches here, and then over here, I click on don't work here, and then I update. Get a notification, say OK. So now the don't work here is the default branch. So go over here. OK. You won't be able to delete the master branch until you update the master branch to this other branch. So in my case, I created another branch. I could have renamed it, but this is just how I do things. In the end, there shouldn't be a main branch or a master branch. The default branch should be the don't work here branch. So now I can delete these branches. So now I can say git branch -d. I think it's called master. I'm not sure if it was main or master. Yes, it was. Git branch -- delete, and then master. Give it git branch. Oh, sorry, wrong. Apologies. Push origin -- delete master. Okay, so I've wiped away that branch, and now I have the don't work here branch as the default branch. Come here, now I no longer have two branches, now I have one branch. So now the next step is to create all these branches. So I have scripts that I use to scrape the data that I have, the student data, and to give me their GitHub, their first name, their last name, and their GitHub username. So one second here, and let's switch over to that. First, let's imagine that these are the students in my class, right? So after I run my script, one second here, it's going to look like this. So this is just simply automates the process of creating all the branches for them. I usually ignore the shell files inside the repository. So now I can come over here. There we go. So, and then I'm going to create all the branches. And ideally, if there are no problems, everything is created. It's all automatic. And now I have all the student branches here. So, of course, these are all fictitious users. But these users here, if these were my students, Dennis Ritchie has his own branch. And when Dennis Ritchie goes through the process of working on this project, he's only going to work in that branch. So, of course, now I tell the students, go online, go to the project. So now we have 9 branches. I tell them, come here, fork the branch. The branch is now forked into their accounts. I tell them that now they can go into the GitHub client, however they want to do this. And when they clone their fork, they're going to have a listing of branches here. So if Linus is taking my class, Linus would click on Linus Torvalds, and then now here he can do all his work. And when he's done, when his project is ready to be submitted, all he has to do is Command R. And from there, it's going to take Linus to, it's going to set up all the branches and have him submit to the correct branches. We don't see this here because I'm working from the original repo, but in a real project, all the branches would be set up and you would see Linus Torvalds, Linux Inventor. Oh, I'm sorry, and I skipped the moment. I skipped something there for a second. So in this case here, it's first name dash last name, right? So it would have looked like this, right? So if these are the students in the class, then it becomes first name dash last name, everything lowercase. followed by a pair of dashes, and then whatever their GitHub handle is. I just made these up, but this would be their GitHub handle, and that's how they're absolutely sure that they're working in their branches. It's possible that there would be two Junio Hamanos in my class. So to make sure that we distinguish one from the other, the username is what clarifies who's working on what. So when they're ready to submit their projects from here, like I said, Command R, Control R if you're on a Windows machine, that's going to take you right to the pulls page on GitHub, and all the branches would be set up. So in their fork, so in the example of Linus, let's say, Linus Torvalds, where do we go? We're right over here. In the case of Linus Torvalds, his branch, where did he go? He's right at the end here, right? He would have a branch that's called Linus Torvalds -- Linux Inventor, and he would be issuing a pull request into that same branch in the original repository, in the source. So all the students end up issuing pull requests when they submit their projects into their swim lanes. So it makes it very easy for me to quickly look to make sure that when they do issue their pull requests, I could take a look and analyze all the branches, make sure that the branches are correct, and then I can accept their pull request into the repository. Now, because they're working in their own, they're working essentially collaboratively, because they can all look at each other's code. I hope, that they're practicing the honor system when it comes to submitting their work. When it's all submitted and it's all inside the repository, that repository stays open, and once they get a grade, it doesn't stay open. I will open it later. Once it gets all pushed in, I close the repository to the public. So, right, the public setting, go to settings, scroll all the way to the tail of the page, right over here, change visibility, and now I make that repository private. It's all kind of put away, they get a grade, and then I reopen it. And students are welcome to look at each other's examples, or rather at each other's solutions, in case they miss something or if they want to learn something from somebody else. Okay, so here's a real-world example of a web design class in which multiple students submitted projects into one master repository here. So the Don't Work Here branch doesn't have anything in it, so if I refresh the page, nothing happens. Let's go into GitHub and, I don't know, let's take a look at Sarah Hall's work. Go over here, refresh, and here is her project. I don't have to go digging around for files. It's all in one place. Let's come back over here. Let's say I want to take a look now at Otto's work. Come over here, refresh, and here is somebody else's work. So switching out between branches during a crit, for example, or critique a student work in a design class, very, very simple. If everyone follows the rules, then everyone would know, okay, this project has to be built in this way. The index document, everyone has to have an index document. Any JavaScript has to go in the JS folder, any CSS in the CSS folder, any images, and so on and so forth. The index.html document is the jumping off point. So very easy to switch between anyone's work here, because all I have to do is switch out the branch and reload the page. So that's definitely a pro in terms of how it is, that I can analyze student work and do this in person. So when we're going through a critique in class, no one has to worry about setting up their Apple display, about switching computers. It's all lightning quick, so we save a ton of time in the classroom. Cheating. Let's take a look at cheating. So I've got Dennis Ritchie's project up here, right? So let's bring up the project in the graphical client here. Okay, so he's got a file.html. Let's say that was the assignment file. And I run a script that will check branches. So I say, let's test to see if how similar this might be to a different branch. Let's do a tab here. Let's take a look at, this is Dennis Ritchie. Let's take a look at Carol Adams. Okay, entirely new in one, not in the other. So we understand how to analyze a diff. Let's try that again, but now let's try it with Alex. And we have no difference there. Sorry, try that again. So in this case here, right, I see that there's absolutely no difference. There have been students who have submitted the same exact project in the past, and the diff renders no difference at all, or sometimes it'll just show a different name. So it makes it really easy for us, or for me, to discover cheating. Another pro of using this this method, this Git workflow in class, is very simply, it's easy to archive the repository, right? A class is over, mark it private, leave it alone. Whatever happens, you have a record of everything. Very recently, I was contacted by a professor in another school. There was a problem with a grade. I was able to simply come back into the repository years later, take snapshots, screenshots, submit timestamps, and so on. We were able to prove that there was a problem with how it is that this student submitted some work, comparing it to somebody else's work and when they did it and so on. So that's another pro of using Git in the classroom. Another pro is that you can see when somebody has submitted something and when they have finished the project. So for example, maybe you have a policy on no late work submission. Easy enough. A student says they couldn't submit it, there was a problem, whatever it is, you can always take a look at their system and very easily say run a handful of commands, and you can see just something as simple as a git log to see when it was that somebody did or performed the last commit to a project. And if it was before the due date but they simply couldn't submit, perfect, then they've all played by the rules, and if there was a snafu there, they still would get full credit. So that's another pro of using Git in the classroom. Let's discuss some of the cons. One con is, depending on which branch you're in, right, you won't be able to see the files that everyone has submitted. You'd have to go deep into working Git from the command line to search for files. But if you did something with a class years ago and you were looking for a file and you were simply using your computer's, your operating system's basic search feature for a file, you may not be able to find it. Maybe that file exists in one branch and doesn't exist in another. So searching becomes a little bit more complex, requires that you understand the command line a little more, or rather at least the command line as it relates to Git. One big con is the learning curve. So students, especially if they've never worked with a technology like this, find it difficult to understand. And from the perspective of the instructor, it's also quite challenging to teach it. I can do a pretty good job, I think, of relaying this information, but it's very confusing. So for one thing, we don't use Git in this manner really in the private sector. This is a reimagining of this branching flow, this branching system in the Git workflow for just teaching. So everyone's always working in the branch. No one is ever issuing a pull request into master or into main. That's against how it is that you typically use Git. So for engineering students, they're breaking away from the common way of working with Git. So they're kind of relearning that. And then for the design students, the people who don't have that much experience or any experience at all with engineering, just the overall learning curve of working with Git is problematic. So the examples component of the Git workflow in class is kind of simple. I almost feel as though I'm insulting your intelligence here. I'll create a folder, call it something very similar to what you see in front of you here. Examples, the name of the class, whatever the course number is, and the semester in which I'm teaching the class. Now, I tell all the students, and let's open this up in the graphical client here, I tell all my students that when they come into class, most of them, if not all of them, already have their own machines. When they come into class, they need to launch GitHub Desktop. to the examples repo. They need to open up the repo in an editor. We use Atom in class. And that they need to have a browser ready. This way, whenever I push anything, they pull and they can immediately see it in their on their computers. So, for example, if I were to make a change here, whatever change I were to make to this file, so it's an empty file, let's just bring up Emmet here, and let's say I add this change here. They cannot edit this repository for obvious reasons. They make a change here that's going to block any pulls from the remote, so they can't touch the repository. If they want to play with this repository, they can always come into the folder and make a copy of this file elsewhere in the file system and play there, but they may not touch the repository itself. They will update the repository as I make changes. So in our example here, I might come in here and say add starter HTML code generated by Emmet, right? I'll push and haven't published this. I'll push, and right here, as you see the push feature here, the progress bar, when they see that reach 100%, then they know to come into the repository and click this button, which is to fetch, and they'll have the changes locally. And if they're following along, if they have their editor up, they'll see the code in their editor immediately. So there is this immediate viewing of code, whatever code that I've written in class, and they don't have to write down or try to follow along. They have the code in front of them. Usually what I will do is I will add a comment to the code, and then I will further reinforce that by making a commit that's along the lines of what the comment, of how the comment reads. So the in-class workflow, just to recap there, very simple. The students, some rules, the students may not touch the repository because it will block. They won't be able to get any more changes. They must launch GitHub Desktop as soon as they come into class. They must launch whatever editor they're using. We're using Atom here, but they can use whatever they want. And then if it's a web class, asking them to immediately launch their browser so that they can see the result of their code. So if this is the file, there's nothing here, but changes that are pushed to them via GitHub, they would come into the browser. I ask them to do Command R or Control R if you're on a Windows machine to refresh changes. They'll see the changes in their code, in their editor immediately, and they can keep their eyes on the board, or on the screen rather, and they don't have to take high detailed notes. They can write notes about the code itself, which is, I think, much easier for them than if they were trying to follow along, which was never really a good idea, but also if they were trying to write notes and code along, that would be near impossible, but some students try. By using this workflow in class, they don't have to worry about the code itself, and they can just write notes about the code. Makes it much easier for everyone in class. Now, for those students who miss class for whatever reason, either they don't come to class, or they come late, or they leave early for whatever reason, they have access to the code. So for example, they miss a class, they can simply go to the repository, update the repository, and any code that was shared that day is now available to them locally on their machine. Another win in terms of using Git in the classroom. So to recap, that's how I use GitHub in the classroom. I simply assign a branch to every single student. They know which branch to work in. They submit their work in the same branch. Makes it very easy for me to switch between branches to look at different students' work. Grading is very simple as a result of that. Running some Git commands to be able to compare two branches or one branch to all the other branches, and this is all automated with scripts to look for instances of cheating. Very simple to do this kind of work, very automatic, and as long as the instructions are clear to the students on how it is that they're supposed to submit their work, then the work of grading and the work of sharing is very easy. In the end, Students learn from each other because, as I mentioned before, all the work that the students submit is, after they're graded, it's reopened to them for them to refork, to update, and then they can compare their solutions to somebody else's, and they're essentially learning from each other, not just from me. Again, some of the cons, for example, very difficult to retrieve files that existed in one branch but don't exist in another branch. That's kind of a tough thing, but it can be done. It just requires some knowledge of how to use Git at the command line. Another con, and big one, I guess, would be the idea that students, there's a bit of a learning curve, especially when using this workflow with students who don't have a technical background, or at least not a strong one. Another con is that students who do learn how to use Git before taking a class with me, they've learned how to use Git properly, and then I'm kind of undoing a little bit of that so that they can work in my class. But those are the small cons. There may be others that I'm overlooking, and there may be other pros that I'm overlooking also. So feel free to reach out to me. My contact info will be provided by GitKon in some fashion, and I appreciate your time.